Welcome to the news. I am your host, Box. On today's headlines, even though farming techniques and technology are much more advanced, farmers are still plagued with forces beyond their control, the weather. Now, we head on to Bonnie, which is on scene in Disneyland, where Farmer Joe can't believe all his hard work has been in vain. Thank you, Box. Right here, we see this poor Joe trying to salvage a situation that has gone catastrophically wrong. Sadly, however, dead crops are not worth much, and this has taken a toll on him.
I hear you out, Joe. I'm Sylvester from Weather & Co. and I am here to help you out. I may not be able to give you control of the weather, but I'm able to give you the next best thing, which is weather instruments. With weather instruments, you are able to profile your area's weather patterns and make accurate predictions of what weather is going to come. And with that, situations like this will never happen again. Remember those times when you were hungry? Well, say bye-bye to those times and hello to food aplenty.
Hello guys, I am Professor D, and today we'll be showcasing to you a few instruments we have in our lab. Alright guys, so here we have a minimum and maximum thermometer, and this is used to measure the minimum and maximum temperature of a day. So the next equipment on our list is this sling psychrometer. This sling psychrometer is used to measure relative humidity of any day. Alright, so the next thing we have is a wind vane. This wind vane is used to measure the direction of the wind. As you can see, there is north, south, east and west on this wind vane. Alright, so the next thing we have is a wind anemometer, and this is used to measure wind speed. Alright, so the last thing we have on our list today is a rain gauge. And this rain gauge is used to measure the amount of precipitation that has occurred over a given period of time.
Hello guys, Professor D here. And today I'm going to show you how to use the minimum and maximum thermometer. First of all, using this, you have to place it 1.5 meters above the ground, as so. The next thing you must ensure is that it's not in contact with direct sunlight. Okay, so after collecting your data, you might wonder, how do you reset this? Well, basically it's very simple. You see this button over here? Just press it once and the whole thing is resetted. And that, sir, is how you use a minimum and maximum thermometer. Alright guys, we're back, and it has been a day already, and let's see our maximum and minimum temperature reading. So first of all, how to read this? Well, you take the bottom of the metal index and you note at the temperature. This is for the minimum temperature, and the maximum temperature, we take a look at the lowest point of the metal index, and then you're done for the day. That's your minimum and maximum temperature for the day. However, these readings might not be so accurate, as during the day, maybe some kind of animal will walk past, and this, like this, for example, emits heat. This might interfere with our maximum and minimum temperature reading, making our data inaccurate. Alright guys, here we have the sling psychrometer. So how do we equip this? Basically, what is this equipment made out of? There's a dry bulb here, the red one, and the wet bulb. This is essential in measuring relative humidity. So first of all, we need to make the wet bulb wet, and we do this by taking water and pouring it in this hole. By doing this, we will then make sure that this wet bulb is wet. So after that, we have to spin this thing away from our body at a constant speed for 1 minute. Alright, 1 minute's over, and now we have to check the temperature on the dry bulb and the wet bulb. And now we take note of these two temperatures and repeat the experiment again for 1 minute. Alright, the next minute's over, and we take a look at the readings again. If the readings are the same, you are done for the day and you can jot down your results. However, if the readings are different, you have to repeat your experiment again, like by doing it for another 1 minute until your readings are the same. Okay, now for the limitations. Well, this equipment relies on the wet bulb the water in the wet bulb evaporating, and when your body emits heat, like over here, this might affect the evaporation rate and thus affect our results. Alright guys, next thing we have is the wind vane, and this wind vane will tell you where the wind is blowing. So first, in order to ensure the correct direction, we must align this north, south, east, west with the north, south, east, west of our compass. Alright, so I think north is over there from our compass, so let's align it right there. Alright, perfect. So once we got this, we must hold it above our head and let the wind do its job. Alright, in this case, you can see that the arrow is pointing over there, and this would mean that the wind is coming from that direction, which is currently the southwest. Alright guys, this wind vane also has limitations. Like if you say you're in an area that has buildings like that, or buildings like that, these buildings might interfere with the wind movement as they can block the wind, and thus resulting in inaccurate wind vane measurements. Alright guys, here we have the wind anemometer, and this is used to measure wind speed. So how it comes in two pieces, and we have to put the two pieces together like this. Alright, once it's in, you must ensure it's working properly by blowing it. See, working perfectly fine. You should be able to read off the scale right here. Alright, so what we do now, basically, well, we have to put this above our head so as not to ensure that any wind is being blown our body. And we look at the wind. Alright guys, and then when the wind comes, you just read off the scale, and right now it's currently 0. So what are the limitations of the wind anemometer? Well, basically it's the same as the wind vane. Like all the buildings around us, these buildings can possibly block off wind. And once they block off wind, they will reduce the wind speed, which in the end will affect the accuracy of our readings. Alright guys, so this is the rain gauge, and how do you set it up? First we put it in an area that is free of any buildings and people walking by, so nothing will interfere with the rainfall. And now we have to put in this speaker inside. This will stabilize the thing, so even when rain falls, it won't fall down. So next thing in this is this collecting machine here. This collecting top will collect all the rainfall and channel it into this beaker right here. And that is how we measure how to set up the rain gauge. Basically, what limitations does this have? Well, rain is actually localized, and it doesn't really, you might measure an area, the amount of rainfall over here might differ from here and from over there. So basically it's very different. So basically it's very hard to calculate the amount of rainfall in one area.
Alright, so basically how do we calculate, how can we derive anything from the temperature, the thermometer? So basically how you calculate our daily temperature, also known as the diurnal temperature, is basically you take the maximum temperature of the day minus by the minimum temperature of the day. So from our results of our thermometer we left outside, our maximum temperature was 35 and our minimum was 25. So basically this means our diurnal temperature range is 10 degrees Celsius. Alright, so now we have to calculate the mean daily temperature. Okay, so let's say, how do we get one of our hourly temperatures? Basically, we take the reading of the thermometer in 1 hour. Let's say it's 25 and 35. Our hourly temperature reading will be these two added together over 2, which means it is 30. So basically, we have to get 24 of these readings, add them all up and divide them by 24, and we will get our average, our mean daily temperature, which in our case is 28 degrees. Alright guys, these are our results from our sling psychrometer. The dry bulb had a temperature reading of 30 and the wet bulb a temperature reading of 25. So basically from this we can calculate relative humidity. There's this table of relative humidity. And then on the left side there will be the temperature of the dry bulb, and then on the top side will be the depression of the wet bulb. The depression is just a change in temperature. So basically the change in temperature of this is 5. So basically what we can see from the table itself, we cross-match the points and we get a relative humidity of 67%.
Oh wow, thanks man. With all this new knowledge, I feel like the greatest farmer ever.
Those are the words I wanted to hear, Joe. I'm just happy to help a fellow man in need. Go ahead, spread the word. Together, we can change agriculture for the better.
Well, there you have it, folks. Another farmer's life made better by Weather & Co. Back to you in the studio, Bob. Thanks for the story, Bonnie. We certainly do appreciate all the work the non-governmental organization has done and hope they will continue with it, providing farmers with the basic knowledge to sustain themselves. It's priceless. Thank you for watching the news.